Hello, everyone. Welcome to the Antarctic Southern Ocean session. Also want to thank you for sticking around for the last session of the meeting. I am Elizabeth Sykes. I'm a professor of oceanography at Rutgers University, and I will be the MC for this session. The Southern Ocean is unique among the world's oceans in that it has ocean boundaries with other oceans rather than continents, and it is unique for the way that humans interact with it. There are essentially no countries that have most of their coastlines bordering this ocean. And so the Southern Ocean's most substantial continental coastline is with Antarctica, which does not have a nation state. Consequently, most of the human interaction with the Southern Ocean is covered by a number of treaties and coordinated by groups that reach across nations. Our speakers and presenters in this session represent the diverse range of science groups that work in the Southern Ocean and coordinate the diverse range of science. The people who I will be introducing shortly are the representatives of these entities and we have been working to develop a coordinated plan for the Southern Ocean, for the Southern Ocean decade, for the Southern Ocean and in the Ocean decade. So the Southern Ocean Task Force, who all of these people are members of, was set up to develop the Southern Ocean Action Plan for the UN decade. And this was coordinated by the Scientific Committee on Antarctic Research, or SCAR. And one of the things we have in the Southern Ocean is a number of entities with lots of acronyms for them. So our speakers today, first will be, we will have Anton van de Putte, who's a member of the Royal or Belgian Institute of Natural Sciences and the Université Libre de Bruxelles. He is on SCAR and is a Belgian representative to CAMLR, which is the Commission for the Conservation of Antarctic and Marine and Living Resources. Stuart Corney is a senior lecturer in Oceans and Cryosphere at the Institute for Marine and Antarctic Studies at the University of Tasmania, and he is the lead for Working Group 4, which is why we have him here today, because Working Group 4 for the Southern Ocean is focused on achieving a predicted ocean where society understands and can respond to changing ocean conditions. Eileen Hoffman is a professor in the Department of Ocean and Earth Sciences at Old Dominion University in Norfolk, Virginia, and she is the co-chair of the Southern Ocean Observing System, another coordination body for science in the Southern Ocean. Eugene Murphy is the head of the ecosystems team of the British Antarctic Survey, and he serves on the Integrated Climate and Ecosystem Dynamics of the Southern Ocean, ICED, and works also with SCAR. I'm Elizabeth Sykes. I suppose I should introduce myself as well. Like I said, I'm a professor of oceanography at Rutgers University, and I am the past chair of the Southern Ocean Regional Panel, which is also part of SCAR and for CLIVAR, Climate and Ocean Variability, Predictability, and Change. And this CLIVAR is part of the World Climate Research Program. So those are the people you will be meeting today. And this session will have both lectures and interactive sessions. I want to point out that you can interact with us by using the chat function, which you can access by clicking on the tabs to the lower right of your screen. There's 3 little icons there. One is for chat, one is for the poll, and another one is for information. The way this is going to work is we're going to start off with a video from Enrique Alvarez of Ocean Predict, who is coordinating this meeting, and that will be followed by our first presentation from our participants, which would be Anton van de Putte. This will be followed by our first interactive session where we have some questions for you to answer and try and get some assess your knowledge and your needs. We will then have 3 more short presentations, first by Stuart Corney, Eileen Hoffman, and then finishing with Eugene Murphy. This will be followed by a second interactive session with more questions. And I just want to reiterate that you are encouraged to interact with the chat function and the poll questions all along the way in your sidebar. Now I'm going to hand this all over to the technical team to present the introduction video by Enrique Alvarez.
Hello, everybody. My name is Enrique Alvarez. I am the technical coordinator of Ocean Prediction DCC at Mercator Ocean International. And it will be my pleasure today explaining our plans to build our community at Ocean Prediction DCC. So our idea is to build a global and transversal community to promote ocean forecasting worldwide. We are not starting from scratch. We are starting from the success of UNEP regional seas and good regional alliances. So we are taking the best of both worlds. And once all these, once our regions are implemented, will be the backbone to provide a collective voice to a wide ocean prediction community. That means going from coastal to deep sea, going from bio to physics, user to scientist, etc. So we want to identify and attract this wide community in order to support the decade action related to ocean forecasting, also to make plans and to develop activities to identify gaps and ways forward, to develop activities for capacity building. For example, if we are able to create one capacity building activity, the regional teams will be the ones in charge of implementing these activities in the different areas, and also for advocate for the implementation of best practices, tools, and standards that we will develop during the decade. We are not doing this in one single step, but we are instead having a step-by-step approach. The first thing we are doing is the kickoff meeting today. So with this kickoff meeting, we are starting the organization and launching the regional teams. This is what all this meeting is about, is just saying hello to the world. Then during 2023, we will be in a second phase for gaining momentum. We will maintain our activities initially through the platform of the event, this Engage platform that we are using for the event. And then once our tool, our web page is ready and our tools or the associated tools will be ready, then we will move our activities to these new elements, to these new tools, and we will start our cruise phase with this web page as focal point. We need to find the best organization for our regional teams, so we are sure that we are able to empower these teams to achieve their objectives. In order to do so, we have a draft terms of reference available for discussion. And some of the points we can discuss now is the convenience of having a regional focal point per region to mobilize the activities, and also to have a steering team formed by experts on different topics, all in all regions, the same topics: observation, physics, bio, climate. So at the end of the day, these experts can talk to each other and can create a worldwide network of experts serving the objectives of ocean prediction DCC and promoting the advances in ocean forecasting, especially focused in delivering as one. These terms of reference will be amended and approved democratically at each regional team. So next steps during this 2023 is first this kickoff meeting. This is just knowing each other, saying hello world. Then we will maintain our activity via the event platform. This will last the following months from January to July. Very important, we will have for each regional team a first working meeting, real working meeting that will last several hours for the presentation, initial discussion of the doors, and launching really the regional team. Then once the web page will be ready and associated to it, we will do the migration from the Engage platform, from the event platform to the new event, to the new platform. That will be around July 2023. Then in the second half of the year, we will start working on creating the plans for capacity development and gap detection in every region. And finally, by the end of the year, we will have another meeting per region that will see the approval, the final approval of the terms of reference, and the final approval of the capacity development and gap detection maps. That meeting will take place around November or December. So as conclusions, the regional teams that we are launching with this meeting will be a key element for the success of ocean prediction DCC. If we are able to fully develop these ideas, including the steering teams, we will end with a very powerful structure to develop ocean forecasting at a global level. The calendar for 2023 is clear, it's realistic, so let's go. And before I finish, I want to thank you for your time, and don't forget to pin your position on our world map. To do that, you will be provided with a link on the chat. Thank you very much, and let's go.
Thank you, Enrique and the team. So our first regional speaker is going to be Anton Bandaputa, and what he is going to discuss for us is the Southern Ocean Action Plan and how we came to that plan, coordinating among global countries and organizations that are interested in the Southern Ocean. Anton, take it away.
Okay. Thank you, everybody. So I'm going to talk about the Southern Ocean contribution to the UN Ocean Decade. So the Southern Ocean, as Liz already mentioned, is sort of a unique case. From our perspective, it is the central ocean that connects to all of the other oceans, and it has no clear boundary. So what we see is we often talk about a biological boundary or a physical boundary, which is a polar front, but that's often very hard to grasp in any kind of treaty. What we also see is that it has a specific jurisdiction. So within the Antarctic and Southern Ocean region, we have the Antarctic Treaty System, which was set up in 1959. So it means that it sort of works in a system which is parallel to that of the UN, with its own rules and member states that are active in that. If you do try to get some lines on the map, the Southern Ocean actually still doesn't have a clear definition. But for instance, this map is from CCAMLR, the Commission for the Conservation of Antarctic Marine Living Resources, and that tries to follow that polar front as the upper limit. Within the Antarctic Treaty itself, it's often referred to as the lands below 60 degrees south, which is this circle in orange that you see on this map. But it is a unique environment with a unique jurisdiction. So when the United Nations came up with a decade, trying to establish the science we need for the ocean we want, we came together with a group of people, which Liz already described in part, the Southern Ocean Task Force, in order to establish a relationship and an informative relationship between activities within the Southern Ocean and those of the Ocean Decade. And so within this task force, Liz already mentioned some of the key players. We have SCAR, SUS, ICED, SCORE, CLIVAR, but we try to reach out as well to engage with industry partners, but also with NGOs active in the regions. And so with a group of people that we sort of found the time to contribute to this, we tried to engage in the process of the Ocean Decade. So we worked around these 7 work packages: clean ocean, healthy ocean, sustainable harvested ocean, a predictable oceans, on which Stuart will talk a bit more, a safe oceans, a transparent and accessible ocean, and an inspiring ocean. And so we went through a process trying to engage a broad group of stakeholders, and I'll quickly go through the highlight of that. So we started this work back in February 2022, where we had an initial workshop co-hosted with the Ocean Sciences meeting in San Diego. And there we looked at a small subset of work packages to work on. Then in 2021, we published quite a lengthy review of all of the priorities that had been identified for the Southern Ocean and the Antarctic region by different programs, such as the Sky Horizon Scan, SUS, ICED, and we tried to bundle all these together to sort of have a benchmark of what was already done in that frame. And in the next step, we tried to engage various stakeholders. We set up a number of working groups to identify priorities, and this sort of culminated in the Southern Ocean Decade and Polar Data Forum Week, where we brought together, unfortunately, still online. We had hoped this would have been an in-person meeting, but circumstances decided differently. So we had this workshop where all of the different working groups brought together their input based on that initial review, with additional information based on surveys and other additional conversations. So this week-long online event gathered more than 400 participants from, again, a wide range of interested parties. So after that, we started working on our action plan, the Southern Ocean Action Plan. That again went through a round of review. And this was published in January 2022. And below you can find the link of that action plan. Now, in addition to the 7 working groups, we found that there were, for us, a number of cross-cutting teams. And so I'll try to go a bit into detail of our findings of these cross-cutting teams. So the bridges we need to achieve for the Southern Ocean we want, it's about funding. It's clear that sustained and long-term investment in observations is quite key. And these constraints are in part linked to the particular environment of the Southern Ocean. It is difficult to operate in. It's quite a harsh environment, and it can be inaccessible depending on the season and on the location. So it's difficult to transport, preserve, and analyze samples. But nevertheless, we need the support to establish a sustained collaborative network of long-term observations by different countries. It's clear that any observations within the Southern Ocean are beyond the scope of just one nation, so it truly needs international collaboration. So it also needs a diversity of funding, national Antarctic programs, regional funding agencies, intergovernment organizations, and others should all try to contribute to observations. And within this context here as well, we've seen a lot of presentations linked to European activities. There's a number of European member nations that have a strong interest in the Southern Ocean, even if they're not closely located to it. So for that, we also need to cross boundaries. We should look at blurring national and regional boundaries. We need to look at bridging boundaries between disciplines, and we need a co-designed global polar research priorities, where we also engage with the Arctic region, because many of the issues we see in the Southern Ocean are shared within the Arctic. We need to continue to identify and connect stakeholders, so improve the dialogue at the science policy interface, which is still quite difficult at times, and ensure that societal needs are reflected and addressed throughout the research that we do in the region. We also need to link the industry with research, infrastructure, and logistics. In terms of data observations and modeling, there's a clear need for improving spatial and temporal coverage, which again is can be quite difficult due to the inaccessibility to the ice or weather of large parts of the region. Ensuring that data and information is fully utilized. So this is making data fair and openly available, so that the use and the investment in money that has been made to obtain those data is optimized. Again, we lead long-term sustainability of observatories and data stewardship. So we need to be able to access data that has been collected a long time ago, and need to ensure that this is also available for future generations. An important component in an area that is relatively data poor is using modeling approaches to overcome data limited conditions. Finally, there's also capacity building. So we need to ensure that there's a diversity of voices at the table at all stages. This includes people that are engaged within the various treaties within the region. But as I said earlier, also non-governmental organizations and organizations that represent industries such as fisheries and tourism within the region. There's also a clear need for capacity building, so that all participants within the processes can have a similar level of engagement, where they have access to the tools, but also have the appropriate training to engage in a level manner. This needs improving of technology for better access. So this includes open access to knowledge, data, and science, but also infrastructure to do observations, infrastructures to do analysis. I went a bit quicker through the presentation than I imagined, but I guess that's not a bad thing. Finally, I want to do a couple of acknowledgements. So a lot of the meetings were funded by the Belgian Science Policy Office. European Polar Board was also quite important in hosting the workshops and the webinars, the Netherlands Institute for the Sea for technical support, and of course the chairs and the Southern Ocean Task Force contact point for all of the working groups and support. But finally, also Annemie Janssens, who I think would have been better suited to give this presentation, but Annemie has moved on to quite an interesting PhD program in Australia, working on kelp. But Annemie was the driving force behind all of these efforts, and she did a stellar work in doing this, and it's a very nice effort by an early career scientist. So with that, I thank you. And Liz, I think it's back to you.
Mm-hmm. Yes, thank you, Anton. That's great. And we are definitely on time, so thanks for that. I think we're going straight to Stuart rather than having the interactive session. Stuart, are you ready?
As always.
Take it away.
Before I start, as is traditional, I guess, in Australia, I'd like to acknowledge the traditional owners of the land on which I'm speaking today. Pay my respects to the Muwinina people who never ceded their right to this land, but tragically did not survive colonisation. So, thanks, Anton, for that talk and giving a great introduction to the Southern Ocean Task Force. So, in the Southern Ocean, as elsewhere on the planet, human presence and the combined effects of various forms of pollution, transport, infrastructure, and the pursuit of living resources, along with accelerated climate change at high latitudes, are exerting increasing pressures on the environment. These changes have the potential to alter the role of the Antarctic and Southern Ocean in regulating global climate and other systems, as well as impacting a host of other important ecosystem services. The situation is further exacerbated due to the unique traits and adaptations of Antarctic species that may make them more vulnerable to environmental perturbations. As Anton has said, the Southern Ocean Task Force was formed to develop an action plan to address the challenges related to the unique environmental characteristics and governance structure of the Southern Ocean. The Southern Ocean Action Plan addressed each of the UN Decade Societal Outcomes. In line with this meeting, though, today I'm going to talk about the outcomes from Working Group 4, A Predictable Ocean. As we've already said, the Southern Ocean has a critical role in global climate. The uptake and sequestration of carbon dioxide, global warming mitigation, and global ocean productivity. The current models implemented for Southern Ocean systems are useful for assessing scenarios of change and future states, but are limited by a current understanding of key biological, chemical, and physical drivers of change and consequent impacts. An integrated view of the Southern Ocean, including its connectivity to global climate and sea level, is critical for predictions of its future states, which in turn flow through to predictions of future states of the global oceans, given the connectivity with other oceans. Predictions at decadal timescales will enable decision makers to develop holistic and timely management responses to a changing environment. Decadal really is a key predictive window. To achieve this, we face a number of challenges. The Southern Ocean Task Force then identified the following three main objectives that we need to work on in our region. 1, improving understanding of fundamental processes and response to change. This objective highlights the need for integrated studies of physical, biogeochemical, and ecological processes and interactions across multiple scales in the three-dimensional ocean, and of responses to changes to multiple drivers. In particular, we need improved understanding of the seasonal dynamics and variation in regional systems throughout the circumpolar Southern Ocean, as this is critical for developing scenarios of change and projection of future states. A second objective, enhancing and expanding observational capability to support predictions. This recognizes the crucial role that sustained observational networks with sampling resolution sufficient to provide a framework of essential ocean variables, data, initial conditions, boundary forcing, and parameterization have in model calibration, intercomparison, and verification. This is in turn critical to advancing predictive capability. Implementation of coordinated international observing programs is critical for the Southern Ocean, both at regional and circumpolar scale. Finally, improving and enhancing Southern Ocean modelling capacity. This objective recognises that modelling needs vary depending on the time and space scales of the desired prediction. Continued development of high-resolution regional circulation models and their inclusion in circumpolar and global models are critical for predictions in this region and to inform decision-making for conservation and for management. In addition to the 3 objectives identified for the Southern Ocean, the task force also identified 4 research challenges that need to be addressed to achieve a predicted ocean. Our aim was to highlight these challenges to encourage activity over the UN decade. Our first challenge then is to improve spatial and temporal coverage of the Southern Ocean. The Southern Ocean is chronically underobserved. The relative remoteness of the Southern Ocean, along with the extreme conditions, means that a lot of the observing activities that are taken for granted in other regions are not yet in place for our region. We're working on it. To succeed in this research challenge, the Southern Ocean community must observe year-round and in more places than we currently do. Our observations are heavily skewed to spring and summer and in a relatively small number of regions. Related to this then is improving our characterization of regional and seasonal variation and variability. This is understanding what happens in different places at different times. Need to improve and expand our observations under the sea ice. This is critical. We've only just begun to observe this absolutely vital part of the Southern Ocean. Similarly, as everywhere, the ocean is more than just the upper tens of meters. It is a complex 3-dimensional environment, and we need to improve our characterization of that vertical movement. As in the Arctic, sea ice is a critical component of the Southern Ocean system. Satellite measurements have allowed us to very accurately map sea ice area, but volume is a much harder problem. It can mostly only be done in situ. To be successful in Southern Ocean prediction then, we must have better measurements of sea ice volume. It's crucial to understanding the thermodynamics of the Southern Ocean and beginning to understand the true impact of global changes in climate to this region. In step with improved volume measurements, better and more widespread observations and knowledge of the ratio of snow to sea ice and density of snow on sea ice is critical. This is even more important than in the Arctic due to the higher precipitation in the Southern Ocean and so greater snow loading on the sea ice. To achieve this, we need to develop better ways of measuring the vertical properties of sea ice, such as thickness and snow ice ratio. Finally, with our newfound knowledge of the system, we must push to develop sea ice models that are specifically calibrated for the Southern Ocean and so reflect the different properties and behaviours of sea ice compared to the Arctic. Currently, most sea ice models for the Southern Ocean began their lives as Arctic models. The Southern Ocean has fundamentally different processes, such as the majority of ice being younger than 1 year old, and using Arctic models will always be a compromise. Third challenge is around observing across trophic levels. As with all oceans, the Southern Ocean is not just a physical system. It is home to many important species. Improving our capacity to observe and model different species, different ecosystems, and across trophic levels should be a key focus of the decade. Eugene's going to talk more about this later as well. We've identified a number of challenges that are key to improving our understanding and representation of ecosystems and species in the Southern Ocean. These are better modelling of primary production and accounting of carbon throughout the water column, greatly increased observations and better modelling of mesopelagic species and ecosystems. Until recently, this important trophic level has been greatly underrepresented in our studies. Improving our models of higher predator movements and distribution. As in all ecosystems, top predators provide an integrated view of the environment, and better understanding their behaviour and what is driving that behaviour is important. Finally, improving our knowledge and predictions of changes in behaviour and distribution of species across trophic levels. In summary, we're aiming for integrated models with end-to-end integration across ecological, biogeochemical processes, coupled life histories of key species, food webs, and biogeochemical cycling, and incorporating projections of carbon cycling and fluxes and Southern Ocean impacts and global productivity. This is needed to elucidate the effects of multiple stresses in the Southern Ocean ecosystems, and crucial again for informing decision-making for conservation and for management. Finally, we come to the issue of scale. Challenge 4 addresses the need to improve regional modelling of environmental variables. To achieve this, we must recognise that modelling needs vary depending on the time and spatial scale of the desired prediction. From a Southern Ocean perspective, the most significant challenges we identified were: 1, the need for improved Southern Ocean specific parameters. Sea ice models are one example, but most ocean models have been tuned to temperate, or global ocean models have been tuned to temperate or tropical conditions. The physical and biogeochemical processes that dominate the Southern Ocean are often unique to this region, and model parameters need to be developed to reflect this. Secondly, carbon cycling through the environment is poorly understood and consequently poorly represented in ocean and sea ice models. We need to improve our modelling of this important component of the system and to better understand carbon sequestration and the likely extent of climate change. As in many parts of the ocean, three-dimensional fluxes are largely unbounded in current models due to lack of observations for comparison. We need greatly improved observations of three-dimensional fluxes so we can improve and have increased confidence in our models. Lastly, the continued development of high-resolution regional circulation models and their inclusion in circumpolar and global models are critical for prediction of ocean ice sheet and air-sea interactions, water mass formation, and freshwater fluxes. That brings me then to my talk. So in conclusion then, the Southern Ocean is unique in that it connects all major oceanic basins, as we've said today. It has a significant impact on global climate, but is often poorly represented in global models. It's underobserved compared to other basins, and so models are often less well constrained or parameterized, which limits our predictive capacity. The UN Decade for Ocean Sciences then presents an important opportunity to address some of the key challenges our community faces in improving our understanding and our modelling of the Southern Ocean. Thanks for your time today. I'd also, as I finish up, like to thank my co-contributors to Working Group 4 of the Southern Ocean Action Plan, and of course the Southern Ocean Task Force leadership, some of whom are here today, for the work we did. Thank you. Back to you, Liz.
Yep. Thank you, Stuart. That was wonderful summary of the work that you did a lot on, and a number of us helped with and explaining the situation in the Southern Ocean, what we need for prediction and moving forward. Excellent. And so our next speaker is going to be Eileen Hoffman, coming again from Old Dominion University, and she is going to speak to us about the Southern Ocean Observing System, for which she is currently co-chair. Take it away, Eileen.
All right, thank you, Liz, and thanks to the two previous speakers for setting up some nice comments that I can make about SEWS and its role in this. As Liz says, I am currently co-chair of the Southern Ocean Observing System. And I'd like to start by thanking the conveners of the Ocean Prediction Kickoff meeting for the opportunity to participate in this session. All right, as I said, I'm the co-chair, but my other co-chair is Sean Henley from the University of Edinburgh, and then also Sebastian Leroux from Norway and Irina Schloss from Argentina are vice chairs of SEWS, and then Elise Hancock is the SEWS executive director. And they're all parts of this presentation that I'm going to give today. Okay, so SEWS is a project that is jointly sponsored by the Scientific Committee on Oceanic Research, SCORE, and the Scientific Committee on Antarctic Research, or SCAR. So there are two parent organizations. The SEWS International Project Office is hosted at the University of Tasmania in Hobart. And there are many other sponsors of SEUS, which are shown on this slide here, and the support from all these sponsors is gratefully acknowledged because that's what allows SEUS to undertake all of its activities. So what exactly is SEUS? Well, SEUS's mission is shown here, and that mission is to facilitate the sustained collection and delivery of essential observations of the Southern Ocean to all stakeholders through the design, advocacy, and implementation of cost-effective observing and data delivery systems. So in the following slides, what I'm going to do is introduce the approach and structure that SEUS uses to advance this mission. Okay, so how does SEUS's mission fit within the Southern Ocean Science Pathway, which is shown on this schematic? All right, well, SEUS interacts with this pathway to enhance the collection and delivery of Southern Ocean observations. And the way SEUS interacts with this pathway is at the red stars that are shown at the 4 spots in this pathway. All right, and so SEUS does this starting at the beginning here by aligning priorities across the Southern Ocean community to provide a unified voice. And I think that's an important task or objective of SEUS, is to provide a community voice that is a coordination across activities. SEUS also enhances collaboration and observational capabilities through developing integrated networks, collaborative tools, which I'll talk about in a moment, facilitating improvements of observing capabilities where we currently have gaps in the observing system. All right, SEUS also ensures the management and delivery of observational data that will meet fair or findable, accessible, interoperable, and reusable data principles. And the last star here is that the knowledge gains from the SEUS observations is made available to all stakeholders. All right, so that sort of gives you a schematic idea of how SEUS interacts across the Southern Ocean in order to facilitate and deliver data. Okay, and so what does SEUS do? Well, it works across multiple large-scale international circumpolar observing initiatives, for example, Argo floats and the Ghost Ship hydrographic transects, but it also works with national and regional observing capabilities here, which are shown in the bottom panel here. There are a number of national and regional programs that are identified around the Antarctic. And so what SEUS does is it works through these groups and with these groups to facilitate integration and delivery of data. Okay, so what guides SEUS's mission? Well, last year, SEUS published a new science implementation plan that provides its priorities and activities for 2021 to from 2021 to 2025. All right, and the science plan is based upon 5 community-agreed themes that were identified as priorities for Southern Ocean observations for the next 5 years. All right, and the 5 themes are shown here. And the focus is understanding the state and variability of the Southern Ocean cryosphere, circulation, carbon and biogeochemistry, ecosystems and biodiversity. And the 5th theme here, fluxes, provides cross-cutting across all the other themes, such as sea ice and atmospheric fluxes. And at the bottom of the screen here, the link to the implementation plan is shown if you want to get more information about each of these. All right, so we have these 5 themes that we're now working on. And for each science theme, key challenges were identified that articulate the priorities for the Southern Ocean community over the next 5 to 10 years. And they're also encompass the scientific drivers of a Southern Ocean observing system. All right, and what's shown here is for each of these themes, there were anywhere between 3 and 6 science challenges that were identified. And what's shown on the slide here is one of these science challenges for each of the 5 themes is shown here. And again, if you want to look at these, you can look at the science implementation plan to look at all the themes or the challenges for each of the 5 themes. But the point of this is that this provides a focal point for identifying the data sets that are needed, and making those data sets available to the community. All right, so what SUS is going to be doing is to work to enhance the collection and the delivery of data to address the different science themes and challenges. And the way we do this is through our working groups, and also by looking at the efforts or working with the other Southern Ocean programs, including the ongoing activities by SCAR and SCORE. Okay, so in addition, how do we continue to implement this? SUS identified some foundational capabilities that are required to address the themes that have been identified. And they're shown here with the blue line that goes vertically here, and then connects these foundational capabilities that allow SUS to then implement a program to look at its different themes and the challenges under the themes. All right, and so the foundational capabilities that have been identified here are looking at observing system design, key variables, and modeling. Modeling is a very important part of what SUS does. Looking at methods and standards for data, and importantly, data management and data delivery. All right, and underlying the themes and this foundational capabilities is the need for SUS to maintain and grow integrated networks and also coordination across the community, because without that, we're not going to be able to implement this. We also have an EDI, or equity, diverse and inclusive group, and we try to make sure that EDI values are incorporated in everything that SUS does. Okay, so how is SUS implemented? Well, SUS has several working groups that are intended to deliver knowledge required to address the different science theme and the key challenges under the themes. And there's a list of them here, but I just want to talk about a couple of these. SUS has a data management subcommittee, and that oversees SUS's data activities, which are core to SUS. All right, and a comment that came up in the video that we heard at the beginning from Enrique Alvarez is the intent to have best practices for data. Well, one of the things that the SUS Data Management Subcommittee has done is that they have developed a best practices document for Southern Ocean data. And so that might be something to further for further discussions as the Ocean Prediction Initiative moves forward. All right, so the Data Management Subcommittee oversees, like I said, the data activities which are core to SUS. All right, so SUS has 5 regional working groups, which are shown on the slide here. And these give circumpolar coverage of the Southern Ocean. And if you look at the map on the Southern Ocean here, the different colors are the regions that are covered by the different working groups. SUS also has a number, and I should also say the working groups have done a lot of synthesis types of activities that look at where the state of the art is and what that tells us about what we need to observe in the future. SUS also has a number of capability working groups, which enhance capabilities in gaps in the observing system. And 3 of the groups are here. One that is particularly relevant here, I think, is the Observing System Design Capability Working Group. And there are also a number of task teams, and these are smaller groups with a defined focus with a shorter timeline. And so 3 of them are listed here. And then also SUS has an Equity, Diversity, and Inclusion group, which is working to improve EDI across SUS, but not just with SUS, but across the Southern Ocean community as a whole, and so that we are as welcoming as we can be. Also, SUS partners and has collaborations with a number of other programs or initiatives, one of them being the UN Decade and the Southern Ocean Task Force. And so SUS works closely with those to advance SUS activities. All right, so SUS has 2 key products that I'm going to talk about here. SUS Map, which is shown on the left here, and Due South. And these are the key products for data delivery. for the Southern Ocean. All right, SEUS map seems to be okay. So SEUS map. This is a figure from SEUS map. All right. So what exactly is this? This is hosted and maintained for SEUS by the European Marine Observation and Data Network, or EMODNet. And what this is showing is the SEUS map interface. All right, so SEUS map is an interactive map of the Southern Ocean with aggregated data layers that can be turned on and off depending on what you want to look at. So when you click on a data point in SEUS map, you're provided with the metadata associated with the data, as well as a link to where the data are available. All right, so the image you're looking at right here shows temperature data from CTD-CAS, Cruel Base, GLODAP, the instrumented seals, and you can do multiple layers here. So this is the distribution of all the data where you can, all the distribution of all the CTD data where you could get temperature. You can also add to this other layers, for example, the polar front, which is the line here, the Antarctic polar front is shown in purple. And if you look to the panel up here to the right, the panel allows the user to explore the data set. All right, and what you can do is click on the different icons and it will show you where the data are and give you access to the data in terms of the metadata, and then you can actually download the data. All right, so what this is doing through SEUS and with the data management subcommittee, we're inserting data sets as fast as we can get them and get them uploaded and integrated into SEUS map. So there's been a lot of discussion about digital oceans, and I would maintain that this is a step towards getting a digital ocean that's based on observational data for the Southern Ocean. All right, so this is a really very nice tool, and I will say personally that I use this for teaching. All right, it's a wonderful resource for students if you want them to go find data sets, learn how to plot them, learn how to analyze data. All right, so the other product is Due South, and this is a database of upcoming expeditions to the Southern Ocean. Due South is hosted and maintained for SEUS by the European Polar Board as part of their platform for polar infrastructure and logistical information and planning, which is PolarDex. So what Due South is you can go to this and it's a database of planned routes, if you will, of expeditions in the Southern Ocean. You can look for upcoming and past programs, routes, whatever you want to call them, as well as you can upload your own information to this. So if you're looking for a program in the Southern Ocean, this would be one way in which you can find it. All right, Due South gets direct feeds from several organizations such as CAMLR. And the database, because of that, provides information on upcoming voyages, flights, and traverses, oceanographic voyages, fisheries vessels, and tourism. So you can search this database and get information about these activities that are planned, ongoing, or have occurred in the Southern Ocean. All right, so at the end here, I would be remiss if I did not mention the first inaugural SEUS Symposium that is coming up this August, and it's being hosted in Hobart, Australia, And the title of the symposium is The Southern Ocean in a Changing World. All right, and so please save the date for the symposium. We are launching the website for the symposium probably the end of this week, the beginning of next week. We had a large number of session proposals submitted for this. The program committee is in the process now of organizing those into the program for the symposium. An abstract submission will be opening soon, so I encourage everyone to consider going to Hobart in August and participating in the symposium. And so finally, what I'll end up here is say that in a summary, SEUS provides access to data that are needed to build predictive models, to do forecasting and stuff in the Southern Ocean. It's constant, models are always needing data, and through SUSH, you can identify if the data exists, and if so, how you can access it. It also helps to identify what other data sets are needed, and that's what the working groups and the capability groups are working on. And as I said before, a SUS map is a step towards a digital ocean. So I'll stop at that and thank you for your attention, and contact information for SUS is shown on this slide. So Liz, it's back to you, and thank you.
Thank you, Eileen, for a very comprehensive description of what the Southern Ocean Observing System is doing. And I think it really highlights how on this aspect, the Southern Ocean Group is miles, not miles ahead, but way out in front. I'm one of the leaders. That's what I want to say. And next, we're going to go to Eugene Murphy, who is going to speak to us about the integrating climate and ocean system dynamics in the Southern Ocean. Take it away, Eugene.
Thank you to the organizers of the meeting. The last couple of days have been really impressive and really quite inspiring in many ways. There's been so many different aspects of ocean prediction covered, and I've certainly picked up a lot of different aspects of that over the last 2 days. And the scale and scope and the ambition of what's being done is really quite impressive. Thank you also to Anton and Stuart and Eileen for doing such a fantastic job going through things. In this talk, I'm going to talk about the ecosystem and the ocean ecological aspects, which is a major focus, and you've heard Stuart talk about this a bit already, and Eileen. It's a major focus of effort in the Southern Ocean, and it's a major focus of the Integrating Climate and Ecosystem Dynamics in the Southern Ocean Programme, ICE, which is what I'm going to concentrate on initially. So ICE is a regional programme of the global IMBA programme, Integrated Marine Biosphere Research, which is co-sponsored by SCORE, the Scientific Committee on Oceanic Research, and Future Earth. It's also sponsored by the Scientific Committee on Antarctic Research. So we formally began in 2008. We've evolved a lot over that time, and there's been a lot of different activity, a lot of different achievements come through. What I put on here is our current vision, which you can see, to understand interactions between climate and ecosystem dynamics and generate scenarios and projections of future ecosystem change to support sustainable governance. So the focus is very much on the future of Southern Ocean species and the future of ecosystems. So as we heard about earlier, that for us, that encompasses aspects of the physics, the biogeochemistry, through the multiple trophic levels, right through to human impacts in these systems as well. And we have 3 research challenges here, which reflect the research challenges of IMBA itself, which is to understand and quantify the state and variability of Southern Ocean ecosystems, to improve scenarios and projections of future Southern Ocean ecosystems at multiple scales. And a key one here, which you've heard mentioned about already, to inform conservation and sustainable management of Southern Ocean ecosystems. So those are the major challenges within ICE. These ecosystems, of course, they matter in their own right, but as you heard a little bit about already, they're really globally important too. They have a key role in biogeochemical cycles, in the drawdown of anthropogenically derived carbon dioxide from the atmosphere. They also influence the export of nutrients out across the global ocean, and hence productivity and food webs and ecosystems throughout the global ocean. They maintain unique biological diversity, and they support significant fisheries. So they're maintaining globally important ecosystem services, but they're also changing. Early on in the development of ICE, we recognized that to understand and address this multiple set of issues with the community that existed, we needed to make sure that we were working closely together, and that we needed to develop whole ecosystem analyses and circumpolar analyses. So ICE has been very much about multidisciplinary activity, integrated activity, and working together. In terms of conservation and fisheries management, this has been mentioned already. CAMLAR provides the regulation of modern day fisheries in the Southern Ocean. the Commission for Conservation of Antarctic Marine Living Resources. It first met in 1982 and it operates under that international convention, the Antarctic Treaty. It's very much a consensus organization making decisions for the Southern Ocean region around Antarctica. It has what is termed an ecosystem-based management framework. So that means that it's looking at not just the exploited species, but also the general health and interactions throughout the whole ecosystem. As global demand for protein increases, there is increased concern about the potential for fishing pressure in the Southern Ocean increasing. So we're very much keeping an eye on that one. So to maintain the ecosystems and global food security then requires that ecosystem-based management, which is central to CCAMLR. And again, it really highlights that we need that whole ecosystem and circumpolar analyses. Over the last decade or so, there's been major advances in our understanding. There's marked spatial and temporal variability in the way that these systems operate. You've heard a bit about this already. There are major regional variations in the structure and functioning of these systems. There are particular species that play a major role in that structure and functioning and in the operation of food webs in supporting many of the higher trophic level species. And that includes some of the key zooplankton species like the Antarctic krill and those mesopelagic fish that Stuart mentioned earlier. We've also highlighted and emphasized and recognized the importance of the interactions that are occurring between species, both in terms of determining the response of individual species to change, but also in maintaining that overall structure and functioning. These systems are also then connected through passive movements associated with ocean currents, which transport biological material and organisms and connect ecosystems together, but also through movements of migration, flying seabirds and swimming of other seabirds indeed, and various marine mammals. And we're increasingly recognizing the importance of global connections of these systems outwards from the Southern Ocean across the Southern Hemisphere, but also into that wider global ocean. So again, throughout this process, we've been developing that whole ecosystem and circumpolar analyses. The challenge of ocean ecological prediction, of course, it's central to what we do, but it's a global challenge and it's throughout all of the regional systems. And there's lots of activity, some of which we've heard about over the last 2 days in the different areas. I've just highlighted one global project there, which is FishMIP, which is the Fisheries and Marine Ecosystem Model into Comparison project. That's developing global ocean ecological modeling and projections. When we're doing this type of projection work, much of what we've been doing so far in the ecological arena is about direct impacts, where we look at the direct impacts of some particular change. It may be due to fisheries or to climate change. We'll look at the impacts on ecological processes and then on ecosystems. We may look at the multiple stressor effects. What we know, and it is present in some of our ecological modelling and fisheries-related modelling, is that the interactions within systems and within food webs can really modify the response of individual species and ecosystems to change. And when we look at some of those simple ecological models, they indicate that such interactions can be important not just for the individual species or the systems, but they can affect things like the biogeochemistry of the region. They can affect the outcomes and predictions. And yet, for most of the modelling that's occurring at the moment, relatively little account is taken of many of these processes in those big ocean models. But we're seeing in some of the models that are coming through that it's showing that it can be important. In terms of provision of advice to policymakers, well, of course, communication and interpretation of projections and predictions is absolutely central. And that involves all of that stakeholder engagement, close collaboration, lots of discussion and co-development. It also requires a continuous assessment of the uncertainty associated with those forecasts that we're making, the projections, the predictions, and then working with the colleagues involved in making decisions to make sure that the risks are considered of different options. And so that we're thinking about trade-offs with the policymakers. And so this is very much an involvement where it requires a specific activity with joint involvement between the people who are closely involved in the projections and the predictions, working with the stakeholders and the decision makers. We've had lots of model development and preliminary projections, I would say, generated for the Southern Ocean. We've got major advances and developed models that are empirical and dynamical. We've got models for key species of various forms, models of behavior, models of aspects of their life history, their distribution, abundance, models of food web processes, how they're impacted by various aspects of fisheries and change. High-resolution physical models have been developed for some areas specifically to look at biological aspects, using things like Lagrangian particle tracking techniques to examine population connectivity and impacts of variability and change, and coupled physical and biogeochemical models, and lots of different elements throughout. Within CAMLAR, there's lots of work on models for conservation and management, looking at aspects of spatial management, and also the development of risk management to consider the distribution of fisheries and their sensitivity of particular areas within the ecosystems. There has been lots of local, regional and circumpolar model development of various different forms, but there's still lots of integration to go and lots of gaps around the continent and in many different aspects that we need to work through. There's been a range of projection modeling work. Most of it has been that sort of more direct impact type modeling, looking at the impacts of change on particular characteristics of the environment on particular groups or species, so zooplankton, fish, and a number of the predators. What we have done over the last few years, and I think is really important to acknowledge, that a really strong early career Southern Ocean modeling community has developed, particularly in some of the ecosystem related aspects. And that's really been exciting to see, and they are really poised to develop and really generate a major change in Southern Ocean modeling over the coming years. To be able to make the projections, the predictions, we of course need to understand the current status of the systems and how they're being affected by change. And a particular group and a major activity over the last few years has been the Marine Ecosystem Assessment for the Southern Ocean, MESO. And this has been led by Andrew Constable and colleagues from Hobart. It's been a core activity of ICED, and it's been developed in collaboration with SUS and SCAR. And it's delivered the first comprehensive assessment of the status of these systems, the impacts of change, and it's being used to inform policymakers and decision makers on the current status and the impacts of change. And that's very much ongoing. It's developed strongly over the last 3 to 4 years, and it generated a whole series of papers with more than 200 authors, and as you can see, from 19 countries. It's highlighted the importance not just of the local conservation and management, things that CAMLAR can do, but also that for the Southern Ocean and the future of Southern Ocean systems, global mitigation measures are absolutely required, and they will be crucial in determining the future of these systems. Just a few words on changes. We're seeing changes throughout the system in ocean physics and biogeochemistry across multiple trophic levels, in biogeochemistry and productivity on plankton, fish, and higher predators. And I will just mention a positive message within that. For some of the populations, for a few species of the great whales, we have seen quite dramatic recoveries of some of those populations. Associated with that, of course, that will be generating big changes in some of these ecosystems, which is something that we have to take account of when we're thinking about change more generally. There's lots of variability. We're seeing major regional variations, differences in the way species respond in different areas. And of course, it's highlighted the complexity of the responses that we're seeing. And it's also highlighted the requirements for new data and improved understanding. So we've heard quite a lot about the data requirements from our previous presentations here, better data, better observations, both in terms of the decade plans and in terms of SUS activities. From an ecosystem point of view, Stuart gave some listing of some specific challenges that we've highlighted. Overall, we need improved understanding of the seasonal dynamics, of sea ice ecosystems, of regional variability, the multiple stresses and ecological connectivity. In terms of model development for understanding, We are starting, and we've already started to develop multi-scale ecological models, but they need to be improved, and we need a more systematic development of those. And that's something where I think the link to the Ocean Prediction Group under the decade is really important. We need downscaled projections, and as mentioned previously, we also need decadal projections. In these areas in the polar ecosystems where we're expecting to see major changes in the next few decades, that is crucial for informing decision making. On a more general point, I would suggest that we require improved understanding more generally of the role of ecological processes in the Southern Ocean, but also in the wider Earth system. In terms of models and projections for decision making, we need regional and seasonal models and those decadal predictions, including those assessments of uncertainty and risk. We're looking outwards to a more broad understanding of the importance of these systems to human systems, the global ecosystem services they provide, but also considering socio-ecological models for these areas to consider how changes in human systems may drive potential change in the future in the Southern Ocean. Just on the right-hand side here, I've got a couple of logos of a couple of projects that we're associated with that are doing work in this area that I just wanted to mention. PolarRes is a European project in both the Arctic and the Antarctic, working with climate scientists to develop high-resolution models for key regions of both the Arctic and the Antarctic, and to generate and to take that information into impact analyses in the ecology systems, in the ecosystems. Biopole is a UK initiative looking at the biogeochemistry and biology of both polar regions and how that then impacts global systems and the global ocean. So there's lots of other projects going on, and I just picked out those two as things that we're involved in at this time. So just to summarize all of that in conclusion, these systems are globally important and are changing. We've got analyses, modeling, projection and prediction that requires whole ecosystem and circumpolar analyses. We have a wide range of models and projections being developed. And the next step requires the coupled and regional models and decadal projections, that integrated modeling that we've been hearing about. It's a major challenge to develop the integration and collaboration that's required. It's a major activity under our plans for the UN decade, and I can see that the links through to the ocean prediction activities here will be really valuable in that. There's a general need, as I've said, for improved understanding of the role of ecological processes in Southern Ocean and in the Earth system. And then finally, in terms of decision making, modeling, projection and prediction requires a very specific focus. It is a dedicated and joint activity that requires effort on all sides and co-development of those activities. So with that, I will say thank you and acknowledge ICE colleagues, the modelling community within ICE and the ICE and MESO communities and all of the groups that we work with across the Southern Ocean. It's a really valuable set of interactions and really important for developing this type of activity. So I think that's it, Liz. With that, I will hand back to you.
Thank you, Jean, for a really comprehensive talk about, again, like Eileen's, really showing where there's a lot of coordination already in the Southern Ocean on some of these topics and how prediction is going to be so important and ideas for how we can take it forward. One of the topics we had some questions to ourselves that we wanted to answer, and rather than project them, I'm going to speak them to the group here, and maybe we can discuss them, because these were things that we thought were important, or things that we need to know for prediction of the Southern Ocean. So on the topic of the fact that the Southern Ocean connects the global ocean, what are the major gaps or deficiencies or requirements for improved prediction in our region? What do we really still need? Does anyone want to jump in and comment on that? I think, we have the SEUS, which is actually connecting different programs and putting resources up online so people can get connected. What we've been doing here is highlighting what we are doing and how the ideas that we do have. But I'm just sort of priming the group and saying, so what are the things, as the group that knows what we are doing, what do we need? What would be something that would be really helpful for improving the predictions in the ocean?
I'll go first if you like, Liz, and
Thanks,
give
Stuart.
others a chance to think, collect their thoughts. Look, having watched the talks over the last few days, and it's been as Eugene said, a really interesting workshop that we've had, and it's certainly for me really been interesting in highlighting what other areas are doing. As a Southern Ocean scientist, and I think all those in the Southern Ocean community understand this in their DNA, is that, you know, how underobserved the region is, with no adjacent populations. As you said earlier on, there is no country whose coastline is the majority of the Southern Ocean. So we don't have those integrated observing systems that, you know, the North Atlantic is well observed around the coast because of, you know, all the populations there. It's the same with many of the oceans. With the Southern Ocean, it is remote to everybody. The challenge of going there and observing is a significant undertaking. So most of what we do, that observing is part of resupply of Antarctic stations maybe, or is a dedicated science voyage that goes every few years. Obviously, the Argo platforms have been a massive game changer over the last 15 years, but even that, it's only been recently that they've been able to observe under the sea ice, or have been able to operate under sea ice. The Southern Ocean, an area the size of, close to the size of North America, is covered by sea ice every year. So, you know, that rules off a lot of the ocean for Argo floats, even that. So chronically underobserved, as I said, and being able to improve that, as we are doing now, and with the advent of ice-capable Argo floats with improved coordination and dedicated programs like SEUS, is really starting to make a difference, that we know what's going on in the regions where we aren't traditionally. And that really is a key challenge for us, and will be a challenge moving forward to continue that momentum and coordinate that kind of activity as SEUS is really leading. I'll enjoy to jump in there and carry on.
Yeah. Eileen, you're muted. Yeah. I can see you're talking.
Of course, I'm muted. Okay. No, I think, Stuart, you hit an important point there, is the ability to observe in and around and under sea ice. And if I was to point to one type of observation that is limiting in most of the models that are currently underway in the Southern Ocean or being developed, it would be the ability to simulate and project or forecast sea ice distributions. And that has implications for the ecosystems at all trophic levels, as well as getting the circulation, air-sea exchanges correct, and all of that. So I think that's an important thing. And I think one of the recommendations from the Southern Ocean Task Force planning document was that, or action plan, excuse me, was to focus on sea ice and sea ice processes and look at the heterogeneity of those in a circumpolar sense, and the impacts of that on the food webs and biogeochemical processes as well. So I don't know, maybe Eugene, you want to add something to that perhaps?
Yeah, thanks, Eileen. I was just going back, stepping back slightly to the question around the connectivity and linking to what you've just been talking about, Stuart, and yourself. And that is, Stuart mentioned it, that one of the priorities we identified within this was the understanding of the full three-dimensional ocean and how the different elements connect outwards. Where are the areas of intermediate water formation? How does that then transfer signals out or material out into the wider ocean? What are the biological areas of connectivity, north and south as well? So actually a focus on those aspects of connectivity may be something within SEUS that we need to think about, how we to make sure that we're generating the appropriate information with the appropriate observations, and think about that from the point of view of the full three-dimensional ocean. And also how then from our point of view in the ecosystem work, from the point of view of how the biogeochemical and ecological processes are operating within that three-dimensional ocean. There are areas where we're seeing strong inflows into the Southern Ocean at depth, and there are other areas where the outflows are very strong to the north. So we don't have a complete picture of that, certainly from the point of view of the biogeochemistry and the ecosystem side of things. And the view from the physics has become stronger over the last several years. So combining that more three-dimensional view is going to be crucial for thinking about this global connectivity.
And I'm going to jump in here and say we do have a question from the audience from Charles. It says, thanks, this is a great overview of the work and collaboration in progress. I'd like to know how well characterized is the southern circumpolar current with respect to driving global currents. Is there specific data that may better bound uncertainty and lead to improved global circulation physics?
Stuart.
I was waiting for Liz to jump in and answer it.
Oh, I was going to jump in and talk about the chemistry, but I'll let you talk about the physics first.
Great question, Charles. So I think there's a few ways of answering that question. The surface ocean, I guess, in the top few hundred meters, is well characterized as to the Antarctic circumpolar current, and the Antarctic circumpolar current essentially loops around. Circumpolar loops around Antarctica, and we know how much transport that is, and we have a good idea of where that goes to fronts and how much water is moving. The key thing for global ocean currents is the overturning circulation, and so that's driven by the formation of sea ice, mostly in the Ross Sea and the Weddell Sea, but also Prince Bay. Sea ice forms that pushes salt into the ocean, creates cold, salty water, which drives down to the bottom of the ocean over the shelf, and that's what is driving that overturning circulation. Which then, we've seen it in a few of our figures, and I had one as well of showing that bottom current, that cold water that heads north away from Antarctica and up into each of the ocean basins. That is really what is driving our global ocean currents, and most of that is going on in very deep ocean, I guess.
Yeah.
And that is where we are, we have an idea of formation, and there's certainly been a lot of work over the last at least 20 years in understanding the formation of Antarctic bottom water on the shelf and near the Antarctic, but what it's doing at 4,000 or 5,000 meters deep as it heads north, that is difficult to observe. It's a long way down and spread over a large ocean. So we could really improve our estimates of, or our observations of that current, or on how much water is doing that. And the variability in that is really a big question, especially moving forward with changes in sea ice concentration and sea ice formation, as to how that overturning circulation, bottom water formation may change in the future.
And I'm going to add, exactly. I think we are doing a good job of characterizing the ACC in the general basis, and certainly the interactions, because the ACC is the only, for Antarctic circumpolar current, is the only current in the ocean that actually reaches the bottom. And so it's unique in that it feels the topography. And that is something that there's been a lot of strides made in describing that interaction and understanding how that steers the current. And for me as a chemist, I really care about that deep water being formed and coming to the surface, because that's where the CO2 gets taken up. I like to say the Southern Ocean is where the ocean exhales. And it also takes up a lot of CO2, but it exhales. And so I think one of the things we don't know is very well is the chemistry of that, like exactly where, and there's been some lovely papers coming out with some of the float work, Argo float work and stuff, getting a better handle on that. But for me, that is why being able to predict the Southern Ocean is so important, because what we're going to see and what we know we're seeing is changes in how much CO2 is getting in and out of the ocean. And basically there's 50 times more CO2 in the ocean that's very exchangeable with the atmosphere. And that is going to change with climate change. So I think that's really, for me, that is, I'm sort of building on that question, that getting to know this overturning dynamic that Stuart described is very important. And I think we're pretty good at what's going on in some of the surface areas, but between the sea ice and the changes in temperatures and stuff, sea surface temperature, yeah, where the fronts might move is going to be really important in getting a handle on. So, and then I believe we had another question that do we have a feeling, do we want to talk about how we can expect that maybe ocean prediction and the work that we're part of here is going to help the Southern Ocean Southern Ocean community in being able to move forward and characterize the ocean better so that we can predict it better, because that's really what we're talking about here. Is predicting the ocean requires having it well characterized. So, well.
So was the question, Liz? Oh, Anton? Okay.
Yeah.
Yeah.
I think for me in general, also in the context of the Ocean Decade, one of the key things is that we try to use this opportunity to standardize a number of observations across ocean basins, and especially the Southern Ocean with that high connectivity. I think it's quite important that we look at that. And there's things like ocean best practices, SUS and other that do tremendous work. And I think, again, in this decade that we have, there's great opportunities there where we can, for me, I look at it from a biological point of view. I'm a biological data manager, but having better standards of what we observe in terms of biology and how we report that, and do that in a way that what we observe within the Southern Ocean is comparable to what we observe in other oceans. And that's, I guess, also equally important for these other oceans, but it is especially due to the high connectivity of the Southern Ocean for that, and this leaky boundary that we have, because we may draw a line on a map, but biology and physics don't really care about that. So I think that's an important component.
Yeah. Yeah, no, and that's because one of the things, there's the different treaties cover different the word I'm looking for is lines of latitude. I'm losing the word, but anyway, so it's all bounded by a particular boundary, but that, like Anton said, that is not where the ocean ends, and that is not where it begins. It begins and ends where it wants. One of the things I deal with all the time in my work is that in the summer, the front is in one place, which is the northern boundary, the southern subtropical front, and in the winter, it's in a different place. And so I think one of the things we've been emphasizing, sort of the sea ice, undersea ice observation stuff, but just getting wintertime observations. I mean, this is the most difficult ocean to work in the world. Even the Arctic is hard in the winter, but the Southern Ocean is harder, I believe. And so getting these year-round observations are pretty important. Okay, so
I think that
it's time for last comments. Go ahead, Stuart.
I was going to say, just reflecting on that and reflecting on what you said, Liz, I think the Ocean Prediction DCC and the Ocean Decade really contributes to that sense of all the oceans are interconnected, and there are so many common challenges that we face, but we often operate in our own basin. And this is a real opportunity for us to be looking beyond that and understanding the common problems, and getting those observing systems standard, as Anton has said, but also understanding where the common issues are and where the differences are. And it's important to understand other people's challenges, us being able to highlight the Southern Ocean challenge, but also understand what other basins are facing as well. So it's that connectivity and the sense that this is one Earth, and we need to have it all together, I think, is a real advantage of the decade and of the DCC moving forward.
Yeah. And I'll just say, very excellent point. And one thread I want to pull out of that and emphasize further is that, most oceans, you have the North Atlantic and the South Atlantic, but we have like 3 or 4 basins in the Southern Ocean that are very distinct. And so, getting those observations together across all these very distinct circulation environments, I think, are really important. Does anyone else want to add any final comments in our last couple of minutes to sum up points they made. Yeah, go.
I just wanted to add on that point about connectivity. These things are not separate at all, and you're talking about it on the physics and the chemistry, and that's right. It's also there in the biology. Many of the organisms, the larger organisms that we've got, of course, move in and out during winter and summer. And so during the winter period, they're operating in ecosystems further north. And so there's a real strong ecological connectivity between these areas as well. So I think the DCC offers us the opportunity to break down some of those barriers and think about how we actually make the connections between these different systems, because many of we're going to see the same sorts of processes that we see, that connectivity in many of the other regions as well. And then, yes, the best practice, the different standardized methodologies, there's certainly things that I've seen over the last 2 days that we can bring into the Southern Ocean and advance some of the things that we've been doing. So, yeah, it's been really valuable. Thank you.
Eileen or Anton, any final words?
Only to echo what has just been said, is that this is an opportunity to understand other systems and improve our understanding of our system by doing so. So I think it's an important opportunity for all of us.
Okay, well, then I will sum up by thanking my panelists, Eileen, Stuart, Anton, and Eugene, for presenting what I thought was a very well-balanced a group of thoughts on what we're doing in the Southern Ocean and what are the needs and for ocean prediction, and highlighting some of the directions we need to go. And I would like to I hope that our audience has learned what they needed to, or learned something from this year, and I look forward to hearing further feedback after this presentation. And with that, I think we're done.
Thank you.
Thank you, Liz, for your chairing.
Yeah.
Thank you, Liz.
Thank you.
And just I'm asking the panelists to stay along for a minute for a post-presentation wrap-up. Thanks.